Okay, this video is 2C and we're going to focus on graphing inequalities when we have two variables. So we're going to graphing on an XY plane, not just on a number line. And we're going to look at how to actually draw the line, how to properly shade, how to look at is a point in the actual solution set, and so forth. Okay, so there's the main objectives here. All right, so a couple of things we want to know about inequalities. Notice before when we had less than or greater than and not equal to, we would do like an open circle. Well, this time, since we're talking about a XY graph, we're going to not use an open and closed circle, but a dashed line, meaning the line itself is not included. So it's almost like an electric fence where you can get close to it, you just can't touch it. Whereas if the actually is included, equal to, notice the line underneath the inequality, then the line is solid and it's a part of the solution. Okay, so it's kind of like open circle, closed circle, basically. Okay, test points basically this. Just like on a number line, if you have x values greater than 5, well then answers like 6, 7, 8, 9, and 10 are obviously solutions because they're within the range where the arrow's at. Well, in a test point here, we want to put in an ordered pair. So test any ordered pair. And you can pick any point on the graph you want. A lot of times we will test 0, 0 because it's easy to plug 0 into the equation. So it's a quick and simple way to see is 0, 0 in the solution, yes or no. And that's how you look at it. Is it a solution? Does it satisfy the equation or does it not? So here we have a scenario where y is greater than 3x minus 4. Is 0, 0 work? So if plug 0 in for y and for x, we find out is 0 bigger than negative 4 when you simplify? Yes, it is. So that means 0, 0 is a solution. So that region is the solution region. And we'll see this on a graph here in a second. I'm just showing you in this graph here how to plug them in. So the same thing over here. Y is less than or equal to 5x minus 2. We plug in 0 and 0 for x and y. Is 0 less than or equal to negative 2? No, it's not. This is a false statement. So this is not a solution. Okay, so you shade the opposite side. So let's take a look at some examples on the graph. All right, so here we have the graph. Y is less than negative 2x plus 4. So the first thing we probably want to do is graph the line. Now notice here it's this less than, not equal to, so I'm going to use a dashed line. So I start at positive 4, slope of negative 2, and there's our line right there. Now, here's where I use the test point. Plug 0, 0 into the equation and see what happens. So here we plug it in. We get 0 is less than 4. Yes, it's true. So at the point 0, 0, right here, this point is a solution. So meaning everywhere on this side of the fence, any point over here, if I picked a point negative 10 comma 0 and plug it into the equation, then the equation is also true. So anywhere in this region is fair game up to this fence line. Obviously, answers over here are not in the solution set and are obviously greater than the equation. Okay, so we want y values less than. Another way to look at it is when you have y values less than the equation, y values go up and down. So if here I'm on the equation, you almost want to do a vertical line. So let me kind of draw it in here, see what it looks like. So if I start anywhere on the line and y values are less than, means goes down. So go vertically down and I shade to the lower half of the line. So that's another way to verify your answer. Let's take a look at another example. So in here, again, I'm going to graph the line first. Now notice here, I used intercept points. So, I just got the x and y on the same side and plug 0 in for y or 0 in for x and solve the other one. So we got that from the other video. Or you could solve for y and then graph with, slope intercept form, your choice. So either way, we have a dashed line, not equal to. Try a test point, plug 0, 0 in. And in fact, we should probably put, parentheses around that to make it true. Plug 0, 0 into the original equation. That way, if you didn't mess up any algebra. And is 0 less than negative 6? No, it's not. So here's the test point 0, 0. Notice it does not satisfy the equation. That's a false statement. So we do not shade this line. That's the false side. So we shade the other side of the fence. Okay? So that's what the test point is, either true or false. That's kind of how you have to look at it. Let's look at one more method here. Okay? Actually got a couple more examples here. So here again, this is in standard form, where x and y are on the same side, so I went ahead and used intercept method. I plugged 0 in for y and 0 in for x and got my intercept points. You can see right here and right here, there's 3 and -4. It is greater than or equal to, so that means a solid line, so the line's included. And we test 0, 0. So we plug 0 in for x and y and find out 0 is bigger than or equal to 12. No, it's not, so the test point is not in the solution set. Therefore, we shade the other side. Okay? And now this one here is a great example because let's look at this line. X is bigger than 4y. Okay, so, to show this, solve for y, put in a slope-intercept form, y equals mx plus b. Notice the b is 0. Our slope is 1, 4. So I'm going to start at 0, and we go up 1 over 4 and so forth. Now notice, if I plug in 0, 0, it's on the line. And clearly it's not a part of the equation because it's not equal to. But we haven't determined what side of the fence. Now again, the only reason why we use 0, 0 because it's easy. But if 0, 0 is on the fence, and you don't know what side of the fence to be on, pick a different point. So here I just randomly picked 0, 3. I could have picked 10, 10. I could have picked this point over here. Pick any point on the graph. So I picked 0, 3. Plug in 0 for x, 3 for y, and let's take a look at our work here. Is 3 less than 0? No, it's not. That's a false statement. So this test point of 0, 3 is false, therefore I shade the other half. Okay. So again, you can test any point you want. A lot of times we tell students start with 0, 0 because it's easy. But if 0, 0 is on the line or any other points on the line, pick any point you want. Pick a point that you think would be easy to test. Even, 1, 1 or something of that nature. Okay? So that's the video here. You'll notice the next couple slides are just more examples of graphing in class. We'll just do a whole bunch of practice problems of this. Again, to highlight the objectives, solid or dashed line and what side you're shading and understanding test points.